Solving radical equations. Learning objective. Solve equation containing radicals. Recognize extraneous solutions. Steps. 1. Isolate radical on one side of the equations. 2. Square root both sides of the equation to eliminate radical, or raise both sides of the equation to the index of the radical, the same index given in the problem. Number 3. Simplify and solve as you would any equations. Do the inverse process. 4. Substitute answers back into the original equation to make sure that your solutions are valid.
There could be some extraneous roots that do not satisfy the original equation and that you must throw out.
The problem that I will ask you to practice is behind the blue box on the right hand side. I will work out the problems on the left hand side to show you how to solve it. We have the answers already given to you. You just have to show me the work so that you can get the credit for this work. The answers is already given, so you can always check it. I'm going to show you how to solve radical equations. The left hand side on this sticky note, we are going to do the inverse operation to take away the square root. I square both sides. But before I do that, I need to isolate that. So I'm going to go ahead and take away 7 from both sides. When I take away 7, I'm going to be able to simplify the right hand side and get -3 for the answers. We have written in the answers square root of 2x minus 1 equal -3. What I did is I isolate this radical expressions, and what I will now do is cancel it out of both sides by doing the inverse operations. And I do that by raising the whole quantity there to the second power. Because it's a square root, I raise it to the second power. If I happen to have a third root or cube root, I will raise it to the third power to cancel it out. If I have a fourth root, I will raise it to the fourth power to cancel out the fourth root. Exactly number of exponent with the roots or the index number. What I will then have is the square and the square root cancel out. We only have 2x minus 1 on the left, and then on the right hand side we will take -3, multiply itself, we will get 9. From here on, you can see we no longer have the radical symbol in, or the square root in the equation, and we're going to solve the equation the regular way. And we are going to do the inverse of subtracting 1. I add 1 to both sides. I will have 10 on the right hand side. When I do that, left hand side cancel out. So 2x equal 10. I know x can be equal 5. We can write out each step, or we can go ahead and skip when we can do some mental math. Because I don't have too much room left on this problem, I skip the step of having 2x equal 10. You can write it if you have space. And then x equal 5 is my final answer. I box it. We are going to leave this problem, by the way, so that you can solve this. Please solve and see if you can get the correct answers. The way that you can check your answers, I will show you in a few minutes. The next problem, we are going to show the solving process over here. I have 10 equal the square root of this fraction, m over 10. What I will do is, because it's already isolated, I can go ahead and square both sides in order to get rid of that square root. I raise both sides by the second power. Because it's a square root, we raise it to the second power. The 2 exponent and the square root here will cancel each other out. I'm going to be left with just m over 10, and then equal to the left hand side, I will get 10 times 10, which is 100. I have m over 10 equal 100. I will go ahead and do the inverse of dividing 10, and that will be multiply 10 to both sides. And so when I get 10 multiplied to both sides, my answer is going to be 1,000. 10 times 100 is 1,000. And this will cancel out the 10 on the denominator here. Remember, it's like 10 over 1. And I cancel this out. Or I get 10m divided by 10, which is m. Remember, I said I would show you how to check the answers. Well, this is one of the source down here. We give you a link to a website where you can get more practice. And it is on the link number 2. This is where I get the problem. You can visit this website. I'm going to go ahead and copy that out. Let's open a new tab. I have to move my bubble to the left a little bit so I can click on the new tab. Paste the address in. Mac Warehouse is where I get those problems to show you as model problems. Remember this example? We asked you to try it. So what you will do is on this website, you can click on the next. It will give you how to solve the problem step by step. If you just click next, it will show you the next step. You try it. If you know how to handle it from here, without the square root, I'm sure you can solve the equation. You can check your answers just by clicking on it. You get the answers and we are done. So always check your answer by substitute it back in. And that's this check part. When we substitute 27 in for the variable, we get the answer square root of 25 equals 5, and that is true. That's how you can check your answers. That is the second link that we have in the source, but what about the first link? The first link is where you can see problem and you can get the answer as well. So check out those sources if you're interested to find out more. To solve these problems, and we are going to do what we have always done, but unlike this problem where I have to do the inverse, the quantity of square root 2x minus 1 isolated, on this one I don't have to do that because we have square root of x over 10 equals square root of 3x minus 58. So right away I can go in and I can do the inverse to get rid of the radical sign or square root sign. I do that by raising both sides to the second power, and that will cancel out the square root on both sides. Because of the limited space in this problem, I am unable to write the problem and show you that step, but we did this so that we can cancel out the radical or square root sign. We're left with x over 10, or which is not a good way to write it, but we are limited in space, so we're going to write it this way. What I will do is I will get rid of the denominator 10, and I do that by multiply exactly that number to both sides. So multiply by 10, and I can cancel out this denominator x over 10. And we are going to also do the same step over here, multiply 10. And what we will do is we will distribute 10 times 3x, I will get 30x, minus 10 times 58, I get 580. Now have variable x on both sides. If you don't know how to solve this, you can check out my previous lesson on solve equation with variables on both sides. We show you the details on how to solve it. We are going to bring x to the same side, either the left or the right hand side. And in this case, I would try to have positive x, so I would just go ahead and subtract x, and then I will end up with 29x on this side. Bring the number to the other side, so I will get positive 580 to the left. But we have, because of the limited space, I divide 29 into both sides, and I didn't write it here. 580 divided by 29, I get x equal 20 to be my answers. As always, you can substitute it back in. We did not show the substitution, the checking part for every single problem, but this is what you can do to check your answers. X equal 20, if I substitute 20 into x, divide by 10, 20 divided by 10, I get 2. and the square root of 2, is it equal or not? We can go ahead and substitute in 20 into x on this right hand side. 20 times 3 is 60 minus 58, I get 2. So square root of 2 equals square root of 2 is true. Answer is checked. We're going to go ahead and show you how to solve the fifth root radical equation. Very similar to the strategy I show you with the square root in the equation. Now it's the fifth root, and we know it's the fifth root because of this index number 5. We're going to go ahead and write the problem on the right hand side. The first step is isolate the radicals. So I'm going to subtract 5 to both sides. The inverse of adding 5 is minus 5. Write the whole quantity with this radical again, and then on the right hand side, 7 minus 5, I get 2. Don't forget, if you all of a sudden leave out the index, you will think this is the square root, and then you will square both sides to get rid of the square root. So this is our index number, and we haven't done anything to the quantity of fifth root of 3x minus 4, so we're going to bring it down exactly like that. What I now have is the quantity of the fifth root of 3x minus 4 isolated. Now I can go ahead and do the inverse to cancel it out. And the inverse, I raise it to the fifth power, the exact same number in that. The fifth power, I do it to both sides, and I can cancel out the radical sign. I have raised both sides to the fifth power. What I can do now is cancel out both the fifth exponent and the fifth root. So I'm going to go ahead and cross that out with the red line. Now I'm just left with 3x minus 4 on the left. The right hand side, I get 2, raise it to the fifth power. That means 2 times 2 times 2, 5 times 32. Right, without any radical symbol in the equation, we are free and clear. 3x minus 4 equals 32. Let's go ahead and solve the rest of this equations, and we will come back to check the answer. Solve the equation and x is equal to 12. We are checking the answer by substituting back in where the x is. We are going to put 12 in. So I'm going to have 3 times 12 minus 4. Take this fifth root plus 5. Is it equal to 7? Let's write it in. I put it into the equation. We can go ahead and use a calculator on this part. We put a question mark on top of the equal because we don't know the answer yet, and that's why we did not box the x equal 12 on the bottom. 3 times 12, take 3, multiply 12, minus 4. So let's hit equal first to make sure minus 4, I should get 32. If I take the fifth root of 32, remember that numbers? Yes, 2. 2 times 2 times 2. 5 times we will get 32. What I will end up with is I'm going to get 2 over here. We can go ahead and write that in the fifth root and everything. We add 5. Is that going to give me 7? So when we have that checked out and it is true, then this is our solution and we can box the answers. Extraneous solution is where you have an answer that is from the outside that is not necessary, that is not true. So that's when we call it extraneous solution. If we don't have it to be true, let's say when you get the answer maybe 3 or something and you add 5, we get 8. 8 is not equal to 7 and this is false or it's not equal, then you're going to say that is the extraneous solution. Extraneous solution is a solution or answer when we substitute it back in and we get false or not equal. Can you say extraneous? Extraneous. Good. Here is an example of extraneous solution. This is a totally different example, and I did not show you the example or the solving process. I'm just showing you how you can clarify that an answer is extraneous. The answer that we have is -3 and -6. When you substitute in the -3, give you a true solution. Answers is checked. The equation is true. But when we substitute in the -6 for the answers, and it is the same equation. We substitute it in and we simplify. We get -4, and then on the right hand side is -6, which is not equal. So this is extraneous solutions and it doesn't work. And that's when you can cross out the -6 as an answers, and you are only left with x equal -3. We are not giving you that just yet. I just want to go through and show you what extraneous solution look like. Another way that you might see problems and you might have to work with square root to solve the equations using the square root method. Steps. 1. Isolate the only square terms or whatever the exponent is. If it's cube root, then isolate that cube root terms, or fourth root or fifth root. Remember to be flexible. Step 2. Solve the values of the x squared by taking square root of both sides. Only when we have x squared, we take square root of both sides. If we have the exact same number of exponent, it's going to be that root on both sides. Step 3. Attach the plus or minus symbol to the square root of the constant. And in this problem, we ask you to solve for x squared minus 1 equal 24. The first step is I would do the inverse to isolate this x squared terms. And the inverse is going to be add 1 to both sides. And remember, whatever we do, we always do it to both sides. So we add 1, and that's this red number that we write in both sides. When I do that, I cancel out the 1 on the left, and I'm left with x squared equal 25. Do the inverse of square on the x by doing the square root. If I have a 3 as an exponent, I take the cube root on both sides. If I have a 4 on the x term, I would take the fourth root on both sides. And the fourth root is where you are writing the fourth index on the outside, just like that, to cancel out the square and the square root. Or the fourth root, then it will cancel the x with the fourth exponent. When we are taking the radical symbol on both sides, remember when we have the right hand side, we will add a plus or minus outside of the square root, and we will end up with two answers, +5 and -5. We can substitute it back in to see if we have extraneous solution. So I would go ahead and do it on scratch paper, or I can do mental math when I substitute it in. If I have +5 squared, I get 25. -1, I get 24. Check, it's good. Extraneous solution is where you have an answer that is from the outside that is not necessary, that is not true. So that's when we call it extraneous solution. -5, I substitute it back in. Squared, I get 25. -1, I get 24. Both of these are the solution, and we have no extraneous solution. Let me go ahead and show you how to solve this problem on the right hand side. We have both the square and the square root. We can go ahead and cancel it out. And what I'm going to be left with is I'm going to have x equal 8 squared will give me 64. Very simple. Box or circle your answer when you're done. I have typed this in so that it can be nice and neat. We will go ahead and show you some guided practice. We will do 1, 5, and 6. The rest will be your assignment. To practice, make sure that you check the answers. K squared equals 76. What I will do to solve it is I'm going to do the square root on both sides. I do the inverse of square on the K. I do the inverse by square root both sides. And when I have that, the square and the square root will cancel out each other. I'm left with just K equal, and I need to simplify the square root of 76 to get my final answers. Check out the lesson on Simplify Radical if you don't know how to simplify square root of 76. Don't forget step 3 in solving using square root method. Attach the plus or minus symbol to square root of the constant. So that's what I have. Plus or minus square root of 76. That's how we read it. And then we simplify the square root of 76. We know that is 4 times 19. And 4 is a perfect square of 2. I pulled out the 2 outside. And I will get 2 square root of 19, not 19. So be careful. This is bad. Don't do this. If you get only 19 is the answer. We got it right. 2 square root of 19 positive and negative 2 square root of 19. We have put in the correct form of answers. When we simplify square root of 76, we get 2 square root of 19. There's a plus or minus in front. That means I get 2 answers. You usually get 2 answers when you have the square on the variable. The next problem I'm going to do is number 5. We have x squared plus a equal 28. What I do is I will isolate the variable terms first. And you will notice that I didn't have to do that step in number 1 because the variable term is already by itself or isolated. So what I will do is I will do the inverse of adding 8. I do minus 8 to both sides. We will continue with the same step for 2 and 3. I have x squared equal 20 after I take away 8 from 28. And what I will do now is I'm going to get rid of the square on the x by doing square root on both sides. When I do that, I'm going to be able to cancel out the square on the x, and the square and square root cancel it out each other because they're inverse operations. We are going to have to simplify the square root of 20 and we will get our answers. And don't forget, we're attaching the positive or negative in front of the square root of 20. We have the x equal plus or minus square root of 20, and 20, when we break it out, we get 4 times 5. 4 is a perfect square of 2, so I move the 2 out, and the answer is plus or minus 2 square root of 5. There are 2 answers in here, a positive 2 square root of 5 and a negative 2 square root of 5. You might see the answer being separate like that sometime, or you can also write the answer together with plus or minus, just like this. Number 6 is the next problem we're working on. 2n squared equal negative 144. I cannot do, well, I could, but I will create more problem if I do the square root at this time. What I want to do is isolate the variable n squared first. So I would be able to simplify it, and I think it's easier that way. So what I will do first is divide both sides by 2. And then I take the square root of both sides, and then I get the answers. I have divide 2 into both sides, and I'm left with n squared on the left. The right hand side, I'm left with negative 72. The next step to solve or do the inverse of n squared is we're doing the square root. What we will have is we are taking the square root of a negative number on the right hand side. Square root of negative 72, no solution. At this time in Algebra 1, we will get no solution. But when you get to the Algebra 2 class, you're going to learn about imaginary numbers. We can continue to solve and get the answers with the eye. I have zoomed in on the last 2 problems to show you a much clearer pictures. We can have the answer form of no solution written out like this, or we can have the 0 with the slash. Not even 0 is the answers, and that's no solution. And that's because we're trying to take the square root of a negative number. It's okay to take square root of a positive number, but when you are taking the square root of a negative numbers, your answer is no solution. Now it's your turn to practice. Have fun.